Hey everyone, welcome back to the channel. Today we're going to have another interesting and nice live stream. So let me just make sure everything is okay like always. And let's start. So in the previous episode, I think forgot, to be honest, I forgot to show you an approach. Okay. I don't know that to call it an approach. Because at the end I dealt with a question that one of you asked concerning the difference between AWS or Stinger and I think it was Render. But my goal was to show you how to lint and to see how the templates are rendered, how the Helm templates are rendered. So it's not ideally an approach, but just something I wanted to see concerning how templates are rendered. So let's get into it right now quickly, and then I show you what I wanted to deal with today. So I'll expand this. So the command, first of all, before you render them, you need to check for possible errors. Okay, there could be structural errors in the Helm chart. It could be a linting error. So you say Helm lint. Okay, so lint is a command. I hope you can see this. Then after typing lint, then you mention the Helm package by saying Helm, okay, / backend. Then hit enter. Okay, so you see it says 0 charts failed. Okay, one chart was linted, meaning it checked for structural errors. Okay, and no structural error was found. Then to test and see the rendering, okay, we say Helm, then template. Template is a command which renders out for you the Kubernetes manifests. Okay, it produces the Kubernetes manifests and fills in, okay, the values in the template, okay, where the template expression language is. For example, if you go to service, okay, the value here will be put, okay, the actual release name will be put, then a dash, then API. Let's check it out. So we say Helm template space, okay, then the release name, we agree it is arrow backend, then space, then the package, which is Helm / package, not package, what's wrong with me? It's backend, okay, which is referring to this one here, Helm backend. Then when I hit enter and maybe zoom out a little bit, you can see everything has been rendered. If you start from up here in the config map, you see we have the name saying arrow backend config. So arrow backend was replaced. Okay, so everything has been rendered. If you go to the config map, okay, you see we only have an expression, then dash config. And that expression says replace the value, okay, of the release name here. Okay, then say dash config. In our case, it is arrow backend dash config. And if you scroll down, you see the same for other areas. So this is how you can render a template. Okay, you can render or use Helm to produce the Kubernetes manifests or the Kubernetes YAML files without deploying. Okay, that's what the template command will help you to do, to render or produce the Kubernetes manifest files or the Kubernetes YAML files without deploying into Kubernetes. So let's see how to now deploy, how to move our image into a pod. The first thing we need is a cluster. A cluster is simply a collection of nodes working together in Kubernetes. A cluster is a collection of Kubernetes nodes. What is a node? Node can simply be a physical machine that gives CPU and memory and disk to your pods. Or it can be a virtual machine, or it can be a machine running in a container, a Docker container. And to create a cluster, we're going to have a setup with only one cluster or one machine for now, okay? And that is going to be done using a tool called k3d. So k3d is a lightweight wrapper, okay, which runs in Docker, okay? It's going to help us to create a single node server. Well, it's not a server, but okay, let's just say cluster, okay? And you're going to see it makes it very easy to create single node clusters or multi-node clusters. But these clusters are in Docker, which will make it very easy. And this is something we want for local development on Kubernetes. Okay, so the first step is to install it. Installing it is very easy. You can use an installation script. Okay, they have this installation script that you can copy, okay, using curl or wget. For my case, I used brew. Okay, I used homebrew. So depending on the platform you're on, if you're on Mac and you have homebrew, simply say brew install k3d and you will have happy days and you'll have great success. It's very easy. So install k3d. Why? Because it is an awesome tool that is going to help us to create clusters in Docker for development on Kubernetes. Okay, and this is going to happen for only local development. Okay, because my machine is not powerful enough to have the real virtual clusters, which are so vast. Okay, but we shall see the multi-node, or can I say a production level kind of setup very soon. All right, so let's go ahead. I'll go ahead and show you that k3d is installed. So I'll say k3d, then say version. When I hit enter, you see I have this version, which I assume is the latest because I installed this very recently. The other one that I need to add to this, maybe just to not add, but to show you, okay, you can check the version of Docker, okay. By now, I expect that everybody has Docker who is watching this playlist, okay. So for Docker, ensure you have Docker. That's how you check that you have a Docker version. For kubectl, okay, kubectl version -- client, okay. This is the tool we shall be using for interacting with Kubernetes, okay. Then of course Helm, okay. I'll say Helm version to check for the Helm version. All right, let's now get into it. So now we have a tool to help us create clusters, okay. How do we create these clusters? Using the k3d tool. But before creating our cluster, okay, we need to start our services, okay, using Docker Compose, okay. Because right now we're going to run a FastAPI application in a Kubernetes pod, but other services are not yet running in a Kubernetes pod, okay. Understand that. So those services are in a compose file. We are going to start them. Of course, later when you're moving to production, we shall see how to use those services in production, okay. And you're going to see them. Actually, we can use the managed services on like AWS or GCP for production. But for now, we're going to leave the other services like Redis, like the database, like Kafka in Compose for now, okay? So that I keep on showing you the step-by-step correct way of how to deal with this. Now, let's start it. I'll say Docker, okay? Compose. Then we choose the local profile, say -- profile, local. Then after that, we can now say app, okay, -d, -d meaning run it in detached mode or in background. Then the services we want to start are database, DB, the Redis, and Kafka, like that. So I hit enter. Okay, says no configuration found. Okay, so I don't know who can guess what the issue is. Okay, it's not that hard. Okay, we need to specify the actual directory because I'm in the root directory here. What I can do is bring up the same command, and before profile, I can simply say -f backend compose.yaml, like that, to specify the configuration file, because it says no configuration file found. All right, so hit enter, and you see they're already running. Okay, so the database, Redis, and Kafka are running. Not bad. Okay, to confirm, okay, you can pull up the same command. Okay, but instead of app, you say ps. Okay, then you get a list. Says no flag d. Oh, sorry. Yeah, I supposed to just remove this. Okay, then you see we have a list of these services. Okay, and it shows that they are okay. So for example, you can see for us who have been dealing with this project for a long time, it was started a long time ago. Okay, so you see this one says 2 months. For some of it might even show 1 year because we've been doing this project for quite some time. So that's how you list using the ps command. Now to create a cluster, you use k3d, then say cluster. Okay, so this is a command group, the cluster command group. Then create is the action to create the cluster. Then after that, you mention the cluster name. Let me make this bigger so that everybody can see. So create is the action to create the cluster name. Then you specify the cluster name. You shall say arrow dash backend, okay, dash dev, because it's a cluster for development. Then I'll hit enter. It says failed to create cluster arrow backend dev because a cluster with that name already exists. Okay, I already created it because I was playing around and trying to understand things deeper. So I hope this makes sense to you. Okay, so for the first time, it will create for you a cluster. Otherwise, it will give you this error message. If you want to see the list of your clusters, you can say k3d cluster list, okay, and hit enter. And there you are. You see, says name, arrow backend dev, tells 1 out of 1 servers, no agent, load balancer, true. I think very interesting. Okay, now when you're creating a cluster, there's something I forgot to tell you. Okay, that when you start your services, okay, using Docker Compose app, okay, Docker adds these services to a network, okay, called backend underscore default. Okay, that network is created automatically by Docker Compose for us. So when we are creating our cluster, we need to add it to the same network. So when you're creating your cluster, okay, make sure at the end you say --network, okay, --network backend underscore default. Why? Because backend underscore default is the network created by Docker Compose for us. Of course, if you want, you can give it your own name, but make sure you add your cluster. Make sure that when you're creating your cluster, it is using the same network. You will have success. Why success? Because the services, which are Redis, Kafka, and the database, are connected to this network. And the DNS, okay, of the cluster will need to find those services. So if we put them to the same network, it will be easy for them to find those services. Okay, so make sure you do that. All right, now after that, we can now build the backend image. Say docker build -t. -t is the option to say we want to tag it. -t arrow. Okay. Oh, hash already. Long time. Sorry, I've just seen your message. I don't know if you're still on the chat right now. Long time. It's been a while. How have you been? And how are you doing? I hope everything is going well for you. Thank you for joining. Makes me happy to to see people who have been right here for some time. All right. I hope you're well, Hash already. So docker build -t. Okay. That's for the tag. We say arrow dash backend. Okay. Then we put the, what is called, the tag. Okay. Say local. Okay. So I want you to think about this. Do you think this will work? Maybe it will. Okay, let's try it. Let me not tease you. Then I hit enter. Okay, says docker build requires one argument. Okay, we need to put the context. So I'll clear up and say docker build -t. Okay, then we put the image name, which is arrow backend, and then the tag will be local. Then the file or the directory having the decompose file is the backend directory. Then I'll hit enter. Okay, so it's building the image and it's done. Okay, that was fast because I've done this many times. So if you look up here, it says cached. Okay, so it picked up stuff from the cache, but the image really exists. So the image has been created, an image called arrow backend with the tag local. Awesome. Now, after that, we can now import this image. Remember, this image that we have created is on our local machine. Now we need to import it into our cluster. We created the cluster, okay, on the same network with our compose services. We have created an image with the tag local. Now we need to import this image into the cluster. So to import it into the cluster, we use the same command that we used earlier. That command is the k3d. Okay, the k3d CLI tool. Hasha, I'm okay. I'm doing good. What am I cooking right now? I'm just trying to wrap up this project, or take it to another level in the DevOps side, and trying to do other things on this channel like system design and yeah, more interesting things coming up. I also want to finish the other playlist on microservices. Yeah, that's what I'm doing right now. Otherwise, outside that, just work. Yeah, work got quite busy, and yeah, it was kind of challenging. Yeah. All right, let's continue. But the good news is that I got a gig one time with a US startup because of this project. They asked me to integrate flights into their project. Yeah, it was some awesome experience. It was nice to see that someone in the USA looked at this project and saw that I was good enough to build something for them. And yeah, I did something for them, and yeah, it was awesome experience. So I hope everything is good with you, and yeah, you can tell me what you're doing right now. So let's continue. So now to import the image into the cluster, I'll say k3d. Okay, then the command group is called image command group, which we shall use to import the image into the cluster. Then we use an action called import. Okay, then the image name. So the image is arrow dash backend, and the tag is local. space, then we say minus C for the cluster. So which cluster do we want to import the image into? This cluster will be the arrow, okay, backend dev cluster. I hope I'm right. Okay. If I'm wrong, we're going to find out very, very soon. And hit enter. So says importing image or images into cluster arrow backend dev. Saying starting new tools node. Starting node k3 backend dev tools. Okay. Saying saving one image from runtime, importing images from Table. It says removing Table, removing k3 tools node, successfully imported image. Successfully imported one image into one cluster. Are you seeing, guys? It's very easy. We have now imported our image, our backend image, into the cluster. In production, you see something similar, okay? In AWS, it's the same concept, okay? Where we shall get an image from a registry into the Kubernetes cluster. Same concept. All right, so I'll remove this. Now, after that, the next step is now to deploy. How do we deploy? We deploy using Helm. Okay, what do? We deploy using Helm. If you didn't watch the past 3 videos, please do. Okay, it will help you understand the progressive step-by-step way I am taking the backend to deployment on Kubernetes in a local setup up to a production setup. So to understand that, at least watch the past 2 videos. Okay, you'll understand everything. All right, nice. Let's now continue. To do that, we use Helm, of course. We shall say Helm, okay, upgrade, and I'm going to explain what this means, minus install, okay. This simply means install the following Helm chart if it does not exist. If it exists, okay, please upgrade it if there is a newer image or newer setup, something like that, okay. So after install, we put the Helm release name, which is arrow backend, will be the release name. And we specify the location of the Helm chart, which is Helm/backend. Okay, like so. Then we create a namespace. Okay, we say the namespace, okay, namespace will be arrow-dev. Okay, if the namespace does not exist, then we should create it. So to create it, we shall use the create dash namespace. Okay, then we say we want the values to be used will be the values in the Helm/backend/values dot not dot but dev, right? Values dev dot YAML. If you don't know what values dev dot YAML is, watch the previous video. Again, I'm going to explain this command. We're saying Helm upgrade install. It simply means that install the following Helm chart. Okay, install a Helm chart with a release name called arrow backend if it does not exist. But if it exists and we have an update, please upgrade the deployment. Upgrade the everything. Okay, if there's something newer. And do this installation or deployment using a Helm chart located in the Helm backend directory. And create a namespace called arrow dev. We're going to use this namespace soon. Namespacing helps you to isolate and not isolate, but to group things under one name so that you can easily access them later. Okay, so the namespace is error dev. But if the namespace does not exist, okay, create it. That's why we're using ---- create namespace. Then at the end, we are saying with values we want to use are in the Helm backend values dev.yaml. So if you don't know what values is, actually what I'm referring to is this. I see this values dev.yaml and values is what I'm referring to. Okay, and Helm backend is this directory. So if you don't understand what values dev, chat, secret, config map, API service, very important that you watch the previous video or live stream. And if you don't understand Kubernetes, I have a playlist on this channel, a very good playlist that covers everything you need to know and to help you get started with Kubernetes. So I'll hit enter. It says release error backend has been upgraded. Happy Helming. Says name, error backend, last deployed, shows the current date and time. The namespace is error backend status. It has been deployed. Revision, this is the 5th. The description says upgrade complete. Test suite, there is none for now. All right, now it is time for us to access our things. We need to see them. Okay, we need to see what is going on. So I'll clean up this. Okay, and now run kubectl. We're going to do port forwarding. Okay, to be able to see our endpoints working or our API endpoints working. So I'll say kubectl is the tool or the CLI tool helping us to interact with our cluster. kubectl -n, okay? -n is a short form for namespace. What namespace? The error dev, okay? Namespace. And what do we want to do? We want to port forward, okay? We want to port forward, okay? The service, okay? So SVC is short form for service. So the service is called error dash backend dash API. Okay. How to understand this? You simply check the Helm chart. Okay. The Helm chart here of API service. Okay. Up here we'll have a name called release name, which is error backend dash API. As simple as that. That is how we get the release name for this. Then I simply then hit, I should not hit enter. If I hit enter, we shall have an issue. Let me do it and you see. Okay. It says type on name and list of ports are required for port forward. Okay. So we need to put the ports. So I'll say 8000 will be for our local machine. Then port 80 is the internal one according to what we set up. Then I'll hit enter. I think it says forwarding from localhost. Okay, this address here 127.00.1 is for my machine, refers to my machine or localhost. 8000 to port 80. Okay, so if I open this in a new tab, okay, and we test, we can say curl, okay, http, sorry, curl http :/localhost / the live endpoint. I hope you remember what live helps us to do. Okay, says failed to connect localhost after couldn't connect to the server. Okay, so something is wrong. And that is because I did not specify the port. So after localhost, I can put : say 8000, hit enter. I think we have good news. It says status live. Okay, that's good. Status live. We can do the same for the readiness endpoint. So I'll change live to /ready and hit enter. You see we get status ready. I see how simple it is to deploy something into Kubernetes. Very, very simple. If you're enjoying this, please like the video, share the video, let people in your network know about this playlist. A lot can be learned for free by just following this playlist. So I'll close this up. And I think that is it. There's some commands I wanted to show you, but they don't cram these commands, okay? you can simply write them somewhere, and every time you need them, you simply look them up, or Google them up, or ask your AI tool. Okay. And if you do it again and again, it will be easy for you to remember. Okay. There's no need to cram. Just understand what you need to do and always look it up when you need it. The other commands I wanted to show you, there's one called kubectl config. Sometimes after you have your k3d okay installed, you need to confirm whether kubectl is connected to the correct context. You can use kubectl config, then check it current. You say current context, okay, and hit enter. Are you seeing? It is referring to the k3d arrow backend dev cluster. Okay. Then you can also say kubectl get nodes. Okay. And you can see we have that node, okay, working as a control plane. I hope you remember what a control plane is. If you don't, simply check the playlist on Kubernetes and you'll be able to remember all this. Okay, then, yeah, I think that's it. Everything is okay. And yeah, we can now have our thing working in the pod. And in the next live stream or video, I'm going to take things up to the next level, okay, until we're able to deploy this in production. So thank you for watching. I will see you in the next video or live stream. Bye for now.